Let's look at the second example problem. This is a LeetCode problem called the subsets. In this problem, you are asked to generate all possible subsets of a set of distinct integers. So you're given a set of integers, they're all different, and you're asked to generate all subsets of that. So in other words, you are asked to generate the power set of this base set. So the input is given in an array, and this is an example. If we have a 3 element, 1, 2, 3, and then the output consists of 8 subsets. So question is how many subsets are there given there's given a set of n elements. So if we have a set of n elements, how many subsets does it have? So that will also decide, it determines how large of n can we handle for a problem like subsets. So this generating all subsets is oftentimes a part of solving some problems. So some problems are solved by enumerating through all possible subsets, and then you do something for every one of the subsets. So the answer is there are 2 to the n subsets, and you should know the proof for that fact. One easy way to prove it is for every element there are 2 choices. You either include it or you don't include it. Since you have n elements, you have 2 to the n choices. And this also means that if we need to enumerate through all subsets, n cannot be too large. So typically you will have n around 20, so you could handle a little bit bigger, but up to around 24. So if it's get bigger than that, then this may not be, the enumerating through all subsets may not be the right solution for a problem like that. So how do we do that? Well, we can use the approach we mentioned earlier, basically using recursion, or this decrease and conquer. So for every element, we can basically have 2 branches. One branch we included and the other branch we don't, and then we just recursively construct the subset. So this is similar to the combination problem, and in fact it's easier because we don't need to keep track of how many elements we have already selected to reach a target as in the combination problem. But there's more, I guess when you write program, there's another way of enumerating that, which is easier by taking advantage of the binary representation of numbers. So using bit operations, you can view there's a one-to-one correspondence between an n-bit binary number and a subset of size n. So essentially you map every element into one of the bit, and you can define if that bit is 1, you include that element. If it's 0, then you don't. So here is a solution for Java code for the solution using this bitmap solution. So we get size n, and then we are creating the variable for the answer. And here, if n is too big, we simply return. We actually don't do anything. And part of the reason is we know the program won't terminate within the time limit, so they shouldn't be giving us that big an n. So then we are just iterating through all the possible numbers up to n, and for every such number, it will define a subset. And we determine the subset by checking the bit patterns of this number I. So if we go through all n items, j goes through all n items. If the corresponding bit for in I is 1, then we will add the number, the j's number. So this construct the subset using the bitmap. So here is essentially the same code in C++. I do want to show sort of one caveat when you use this bit operator. So for example, this is so this is a C++ code. Actually, I'm curious the similar code in Java, what would happen. But this is a C++ code, so the question asks you to predict what this code will generate. So I will go through 0 to 60, but at interval of 10. So this will print out 2 to the 0, 2 to the 10, 2 to the 20, 2 to the 30, 2 to the 40, 2 to the 50, right? So that was the intention. So because 2 to the 50 and 2 to the 40 and 2 to the 50 will be bigger than what can be represented using 4 bytes, so we use the long here. So we expect this will print out the powers of 2 up to 2 to the 50. But if you run it, here's what you got. So up to 30 is correct. So we have 1K, 1 meg, 1 gig. But for 40, we actually have a very small number. And the reason, so I want you to sort of understand exactly why this happens, and hopefully then you will avoid it in your own coding. I think I actually might have made this had this bug in one of my programs. So the reason is this expression is interpreted from bottom up. So the first part that's got interpreted here is this one left shift I bit. But 1, the type of 1, when we write it, is by default int. So this is a 4-byte int. So we are shifting this 4-byte integer 1 to the left 40 times. Then this will just wrap around. So we'll get actually, instead of 2 to the 40, we get 2 to the 8. So if we want to do this the right way, this should be 1L. So to tell the compiler that here we want a long integer.